Hi all, so today we're going to be working with composite functions, and this just means you're plugging one function into another function, and you're plugging the output of one function into that other function. So let's look at an example. So we can rewrite f of g of 1 like this, and we want to look at the innermost parentheses first and find what g of 1 equals. So we're going to find if we input 1 into g, what's the output. So I'm going to look at my g function, which is 4 of x. So 4 times 1, which equals 4. So now I'm going to take the output of that g of 1, which was 4, and just substitute it for what we had written in the beginning. So now we're going to find what f of 4 is. And so we're going to have 2 times 4 squared minus 3, which is 2 times 16 minus 3, 32 minus 3, which is 29. So you're finding if I input 1 into g, I get my output of 4, and I plug in the output into the f function. So let's try now of g of f of 1. I'm going to input 1 into the f of x function. So 2 times 1 squared minus 3, which is 2 minus 3, which equals negative 1. That's my output of when f equals 1. And I'm going to take that and plug it into the g function. So 4 times negative 1, which equals negative 4. All right, so f of negative 2. First, I'm going to plug in negative 2 to the f function. So 2 times negative 2 squared minus 3, which is 2 times 4 minus 3, 8 minus 3, which is 5. Now I'm going to plug in that output into f again. So 2 times 5 squared minus 3, 2 times 25 minus 3, 50 minus 3, which equals 47. Now g of negative 1. So I'm going to plug in negative 1 to the g function, which is negative 4. I'm going to take that output and put it back into the g function. So g of negative 4 now, and that is 4 times negative 4, which equals negative 16. Okay. Now we're going to be doing f of g of x. So this time we're not given a number to plug in, and we're just needing to plug in g of x into the function of f of x. So everywhere we see, so f of g of x, everywhere we see the x value in the f function, we're going to plug in g of x. So everywhere we see x in the f of x function, we're plugging in 2x plus 3. So we have an x squared first, so 2x plus 3 squared, plus 3 times x, so 3 times 2x plus 3, and then minus 1. If I multiply 2x plus 3 times 2x plus 3, which is 2x plus 3 squared, I get 4x squared plus 12x plus 9. Here I'm going to distribute my 3, so I get 6x plus 9, and then minus 1. Combine like terms, I get 4x squared plus 18x, and then my plus 17. Now they want us to also find the domain. 2x plus 3, which is g of x, is a line, a linear line, and the domain is all real numbers. And then f of x is a quadratic function, which is also all real numbers. So that means f of g of x is going to be all real numbers. Okay, now we're going to do g of f of x. So I'm going to plug in the function f into anywhere I see an x in the g function. So I have 2 times x, so I'm going to do 2 times x squared plus 3x minus 1 plus 3. So I'm going to distribute the 2 to each piece in the parentheses, and I get 2x squared plus 6x minus 2 plus 3. Combine my like terms, I get 2x squared plus 6x plus 1. And then now we're going to find the domain. Again, these are it's a line and a quadratic, both having domain of all real numbers. So our domain again is all. Now we are going to look at when we have rational functions, and if we remember from before, we have to restrict our domain because if we can't have a 0 in our denominator because that makes the function undefined. So let's look at the domain of g of x first. So we would say x minus 1 cannot equal 0. So that means x cannot equal 1. So our domain is x such that x cannot equal 1. Now let's look at f of x. We have x cannot equal, or x plus 2 cannot equal 0. So x cannot equal negative 2. So x such that x cannot equal negative 2. So if I plug in negative 2 into the function of f of x, I get a denominator of 0, which is undefined. But I need to remember, when I'm doing f of g of x, I'm plugging in the output of g of x into f of x. So that means my g of x cannot equal negative 2, because if it did, then this would make it undefined. So how I'm going to solve that is set g of x equal to negative 2. And then solve for x. So I'm going to start by multiplying both sides by x minus 1. And that gives me negative 2x plus 2 equals 4. I'm going to start solving for x. And I get x equals negative 1. So the domain of this function is x such that x cannot equal negative 1 and 1, because if we automatically put 1 into g of x first, that gives us undefined and we couldn't even move forward to doing f of g of x. Okay, so let's go and find, now they're asking us to actually find what f of g is, and then also find the domain. So f of g of x, we're going to plug in g of x into the x value in the f function. So 1 over 4 over x minus 1 plus 2. I don't want that fraction in the denominator, so I'm going to multiply the top and bottom by x minus 1. So multiply. And I would get x minus 1 over 4 plus 2x minus 2, which simplifies to x minus 1 over 2x plus 2. And we know from above that the domain is x such that x cannot equal negative 1 or 1. Okay, now we're going to do g of f and then find the domains. So again, I'm going to start by finding g of f of x. So I'm going to plug in the f function to x in the g function. So 4 over 1 over x plus 2 minus 1. Get rid of the fraction by multiplying the top and bottom by x plus 2. I get 4x plus 8 over 1 minus x minus 2, which simplifies to 4x plus 8 over negative x minus 1. Now find the domain. So we know that the f function, the domain f of x, from above, we know x cannot equal negative 2. And we know g of x cannot equal 1. So we need to now figure out, okay, so I'm plugging in the output of f of x into g of x. So it cannot equal 1. So I'm going to set f of x equal to 1. So 1 equals 1 over x plus 2. And then times x plus 2 on both sides. I get x plus 2 equals 1. And then x equals negative 1. So my domain here is x, such that x cannot equal 1 or negative 1. This won't always be the same where the domain of the reverse is the same. So you always want to check. All right, for this next problem, we are going to see of f of g of x equals g of f of x, which also equals x. So let's start with f of g of x. So I'm going to plug in g of x into f of x. So 3 times 1/3 x plus 4 minus 4. And that gives me x plus 4 minus 4, which gives me x. Now that gave me x, which is good. Now let's see if f of g of x or g of f of x works. So I'm going to plug in 3x minus 4 into the x value in the g function. So 3x minus 4 plus 4. I can cancel those, and I get 1/3 times 3x, which equals x. So check, check. And this gives us a little preview for our next unit, that if this happens, then that means the functions are actually inverses of each other. If you have any questions, please feel free to come ask.